Okay, so we're on section 11.4 now, and we're going to be talking about graphing quadratic functions that have transformations happening to them. So before I get into this, I want to talk to you about, first of all, just what the graph of f of x equals x squared looks like. So f of x equals x squared. This is your most basic quadratic function. This one is actually called the parent function to all quadratic functions, okay? You want to have this graph memorized. I'm going to show you how to make a table of values for it, and we're going to graph it over here, but it's really not something that you should make a table for every time. You should just kind of have this one memorized, okay? And you'll see why when we get it graphed. It's pretty easy. You want to pick some positive numbers and some negative numbers, and I usually just pick the 5 same numbers that surround 0 and include 0. So I'll pick x numbers that are from -2, -1, 0, 1, and 2. Now you can put fractions in here. You can put whatever you want in there. I choose those numbers because those are easy and they're small. You're going to put that in to the f of x function, which is x squared, which means you're going to square it. So I'm going to do -2 squared, which would be +4. Then I square the next one, -1 squared, which would be +1. 0 squared is 0. 1 squared is 1. 2 squared is 4. This is your x value, and this is your y value of your ordered pairs that make up your parent graph. Can you see the pattern here? You see it? It repeats itself, doesn't it? Well, of course it does. You saw what these graphs look like. They curve around like that, don't they? So they're going to, of course, have some repeated y values. So I'm going to graph it. -2, +4. -1, +1. 0, 0, 1, 1, and 2, 4. This is not something you use a ruler to connect, which I know you're graphing on the computer, but it's supposed to be a smooth and continuous curve. So it's something that you're supposed to be able to draw without picking your pencil up. It's supposed to look the same on the left and the right. It doesn't, but it's supposed to. This point right here is called your vertex. It is the turning point of your parabola, okay? There is an imaginary line that comes through the vertex. It's a vertical line. It cuts the parabola in half, and it is called the axis of symmetry. And I always abbreviate that AOS. It's spelled out in your book somewhere in this section. And again, that parabola should look the same on the left and the right. Mine's a little crooked. This is a parent graph of all quadratic functions. So from here, we can learn how to transform them. If you have f of x, this is a general form, equals x squared plus k, k being a real number that you're adding out there. This indicates a vertical shift It's actually called a translation, a vertical translation. or down k units from the parent graph. So if it's a plus k, you would move up k units. If it's a minus k, you would move down k units. This is your easiest transformation. So if I gave you, if I said graph x squared, I'm sorry, not x squared. It will be, but I need to put something else first. If I said graph f of x equals x squared plus 2. Now, you can go through and make a table of values for this one. But if you understand that this plus 2 added outside the x squared indicates a vertical translation up or down k units from the parent graph, then I can simply go, oh, this means move my parent graph up 2. And I can just take all the points on it and move it up 2. Supposed to be curved, not straight. I'm sorry. I'm struggling. But that's the answer to it. That's how you graph it. So I'm not going to graph this one, but I'm just going to ask you, what does this mean? You tell me this. So let's call this one g of x. G of x equals x squared minus 3 over 2. So how would that one translate from the parent graph? The minus means what? Down. How many units? 3 over 2 units. How many units is that? How many blocks would I move the parent graph down? 1 1/2 blocks. 1 1/2 units. So everything would end up in the half, wouldn't it? So I'd move this vertex down 1 1/2. My new vertex would be right there where my pencil is. Okay? I'm not going to graph it. I just wanted you to tell me, what was it doing? Okay? Next thought. So if I ask you to graph one that's in this form, f of x equals x minus h quantity squared. Now I want you to notice something. The number h is a number, is not outside the parentheses. Where is it? Inside, before the squaring takes place. Happens to the x before you square it. Well, that doesn't mean you move up or down. This means you move up or down. What do you think this means? Left or right? Okay, so now left and right is tricky. So this indicates a horizontal translation. Left or right h units from the parent graph. Opposite the sign. This is where it's tricky. My pen is doing something funny. So if it says minus, you actually move it to the right. And if it says plus, you actually move it to the left. That's why horizontal translations are confusing. Vertical translation are what you see. If it's plus, you go up. If it's minus, you go down. Horizontal ones are opposite the sign. Minus means go right, not left like our brain wants us to. And plus means go left. Okay? So, this example, if I asked you to tell me how this one would shift, f of x equals x plus 4 quantity squared. How would it translate from the parent graph x squared? Left, how many units? 4. Now, if I took time and plugged in numbers, made a T-chart, a table of values, and plugged them in, my graph would be left 4 from my parent graph. It works. These are just shortcuts. So let's graph this one. I want to graph it up here. Is that okay? You ready? I'm going to use a different color. I'll do this one in blue. So from the parent graph, it would go left 4. So this is x plus 4 quantity squared. F of x equals. The red one is f of x equals x. It was plus 2, right? Yeah, plus 2. X squared plus 2. So if it's happening after the x is being squared, it's up or down. If it's happening inside the parentheses before the squaring, then it's left or right opposite the sign. Any questions on that? Who has done this section on the Alex? So we're going to look at one more where there are more than one translation happening. Okay. For the function f of x equals negative x plus 2 quantity squared minus 1. All I want you to do is tell me what sorts of translations would be going on. I haven't mentioned yet what this negative outside the parentheses does, so I need to mention that. If there is a negative outside of the parentheses or outside or in front of the x squared, that means the graph is going to open upside down. It's technically called a reflection over the x-axis. Okay? A reflection over the x-axis. So, we're going to just describe the translations that this one would make. The one that's on your exam and on your exam review is not like this. Okay? I don't even know if they're going to make you do one like this, but we're going to look at it. So I've already said that it would be a reflection over the x-axis. That means instead of opening like this, it's going to open like this. That's what it means. Okay? All right, now, what does the plus 2 inside the parentheses with the x do? Left, how many? Left 2. And what does the minus 1 do? Down 1. And of course, the reflection over the x-axis would also be written down there. So if I were to take the parent graph, and I'm going to actually graph this one for you so you can see what it would look like. Uh-oh, let me undo that. Put it right here. Okay. Let's graph our parent graph first. We'll do it in black. 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. This is your parent graph. I'm going to dash it in because it's not my real graph. That's my parent graph. Gosh, I cannot make that straight on this. Now I'm going to reflect it over the x-axis. So that would cause it to do this. That one that's 1 above would now be 1 below. This one that is 4 above would now be 4 below. It would look like this if I reflected it over the x-axis. Then I'll move it left 2. So every point would go to the left 2 and down 1. So this point's going to go left 2, down 1. This point's going to go left 2, down 1, left 2, down 1, left 2, down 1, left 2, down 1. This is the graph of that. And I did that by knowing my translation and transformation rules. Okay? You will not be tested on one like this, not in my class. If you have to take another class, you will. Okay? But you've been exposed to it. All right. I actually think that is it.